Okay, as promised, we're going to have some ratio table lessons. So what I've printed out here is page 10 of the Understanding Ratios worksheet. It starts with Dave playing checkers with his friend. The ratio of games Dave won was 10-7. If Dave won 80 games, how many games did his friend win? So this is 10 goes with Dave. And this must be his friend. So the first thing we really do is identify the labels. So we have Dave, games won, friend, games won, which probably means that idea of total is going to be total games, which would be 17 here in that ratio. So I'm going to go and set up my ratio table for number 1. So Dave won, friend won, and total games. So I'm not really paying attention to what it's looking for just yet. The first thing I want to do is put in the numbers that I've identified here. And I'm going to come back to the problem, see if there's any more information before I continue. If Dave won 80 games, so this goes with Dave, I'm going to come up here and put in 80. Now, I know it's going to ask me a question, but once I have this information in here, I'm able to identify how do I change 10 into 80. And remember, these are equivalent fractions. This is the same as 10/7 equals 80 watts. So we're identifying that we are multiplying by 10 to move from this column to, not 10, Roner. We're multiplying by 8 to move from this column to this column. 10 times 8 is 80, 7 times 8, 56. Now, when we're moving vertically, we can add and subtract. If I want to check, I could check what is 17 times 8. 17 times 8, 56. Regroup the 5. 136, that checks out both through addition and through multiplication by 8. I'm going to come back to the problem now that I have the table all filled out and see what it's really asking for. How many games did his friend win? So ultimately, inside of this table, this becomes my final answer of 56 games. Always have a label because there's always context. Let's look at number 2. So the first thing I'm going to do is try to identify what my 3 labels are. If there is a third label, sometimes there's not an idea of total, but a lot of times there are. A restaurant offers diet soda and regular soda. Well, right off the bat, I know there's diet soda, regular soda, and so I'm pretty sure there's going to be an idea of total sodas. So if I want to set up, I have diet, I have regular, and I have total sodas. Always get those labels in there. Everything that goes up on this top row is going to be diet soda. Everything that goes in the middle is regular soda. And then the sum of those 2 items is going to be that third column. Now we go back to the problem and we see what we can fit in. Let me just slide this up a little bit. See if we can fit both of those in. In one day, they sold 24 diet sodas. All right, well, we'll fill that in. If the ratio of diet soda sold to regular soda sold was 8-1, so 8 comes first, and so does diet sodas. So I know that the 8 goes with diet sodas, and the 1 goes with regular sodas. 8-1 needs to stay together vertically. So because I already have something filled in there, I'm going to fill that in there. Meaning for every 9 sodas they sell, 1 should be regular and 1 should be diet if we're maintaining that proportion. So I can immediately see, I'm not even looking at the problem right now. Now I want to fill in my table. I'm working in this direction and multiplying by 3, which means 3 times 1 is 3. I can add to get 27. I can check is 9 times 3, 27. That does check out. I come back to question 2 and say, all right, what's it really want from me? How many sodas were sold total? My total here is 27 sodas. Okay, third type of problem, and the last one for this video. Oh goody, a carnival one. Let's see. Get it folded so I can fit it in there. Okay. At a carnival, Luke bought 33 tickets. If he used 3 tickets trying to win the ring toss, what is the ratio of tickets he has to tickets he's used? I think this is the most difficult type of problem to set up. It's kind of gotten some hidden labels. So again, I really want to focus on those labels first. What are those ideas going on here? Again, not everything's going to have this idea of total, but this one does have it. As I read this, I see 30. I know something has to do with tickets, so I got to keep going. He used 3 of the tickets. And then I want to know, and I think this is where I'm going to find my real ones. Tickets he has to tickets he's used. So tickets he still has in his pocket, tickets he's used, which means this is the total tickets that he started with. This is confusing because they give you the total to begin with. 33 tickets is what he started out with. And many students want to fill that in here for has. And if he uses 3, that means he started out with 36, because 33 plus 3 would be 36. Might as well write that in there. This is incorrect. And this is really our error alert. So where in the problem did it tell me he had 36 tickets? And a student may say, well, maybe he had one in his pocket. Sadly, if the problem doesn't tell us that he had 3 more tickets somewhere, he doesn't have 3 more tickets. So we really can't start with 33 and end up with 36 when we set up the table. So 33 tickets here is our idea of total. If he used 33 tickets, used 3 tickets out of the 33, that means he still has 30 to use. I can extend the table to continue working with it. Let's go back to the problem, see what it wants now, or if it gives us any more information. It's looking for a ratio, so I'm going to end up writing this either with a colon or the fraction bar, or with the word 2, of tickets he has to tickets he's used. You could do has used as a fraction, has to used using the word 2. So we can come back in here. I could write this ratio as 30 to 3, but that is not the simplest whole number ratio form. And when we talk about the simplest whole number ratio form, we really want to write it as 2 integers, and we want them to be the smallest integers we can really come up with. So I can divide both of these numbers by 3 and get 10 wholes, which would add up to 11 tickets. So for every 11 tickets, he's used 1 and has 10. So then I can simplify this to 10 to 1. My final answer, when I write it over here, is going to be 10 to 1. That's going to conclude the first 3.